Okay, so let's take a look at this question on word break 2, and we'll be doing it just like Google mock interview style on a Google Doc. So the question states that we have a string like this cats and dog, and we have a dictionary like what words are possible like cat, cats, and sand and dog. We need to make an output of all the combinations that are possible to make this. So the end result must be that this and the join of this should be the same. So if we see the output, if we join these, then this becomes cats and dog, and this also becomes cats and dog. But another important thing is like you can see that these are the words that come from the word dictionary. So we are not just splitting it like as it is, we are using the word dictionary and we are using that to make a combination of words that could be used. And just take a second example, like take a look at the second example where we have apple apple and we have a word dictionary, and we can actually reuse the same word infinite amount of times. So we can just reuse it n number of times that we want. So this is one particular question if that interviewer asks you, as I used to say in every of my videos, that let's first think. Yeah, so let's first think. uh, One of the thought process for me is like if I am making any kind of for loop, maybe brute force or maybe recursion, then my base case would be if the string or my counter, like let's say I, is equal to my s dot length. So if we are thinking of a recursive solution, which there would be in this case, my thinking would be like, yeah, this would be the base case, because uh, the way I can see it right now is that if I make a loop from here to here, my I, in any case in my output, let's say there are multiple outputs, the length of this is equal to the length of this if we just ignore the white spaces, right? So somewhere somehow we are just using the word dictionary and we are joining our answers that we get from the word dictionary with a space. Let's say we are just joining it and we're using a space. uh, so one of the things, like first question would be like, can you brute force this? So let's just think that to brute force this, the very first thing I want that I can have constant time lookups when I am checking my word dictionary. I don't want to use something like includes in JavaScript. So what I can do is, and this is like still a pseudo code, const word dict is equal to new set. And the very important thing about set is that set has a constant time lookup. We can call this word dict set. Yeah. So right now if I do something like I'm sure that if we have some loop that is running in s and we have some s substring, let's just think that it is some kind of a substring that we have or a slice that we have, then if I do something like this substring of has some kind of a start and some kind of end, which is like a two for loop that is giving me this, so I can make a constant time lookup that does this exist in my word dict or not. So could be something like this could be const uh, word, and we can just have a lookup like word dict set dot has word. And why did I do this? I am just thinking about my approach where maybe I have some kind of loops that are running, maybe two for loops that are running, and I am just thinking about it like uh, that could give me, if not both of my answers like here, at least one of my answers, like if I do cats and dog, and maybe it will be able to check at one time in the for loop when I have a start and end, it may be able to check like this cat exists in this word dictionary, and then maybe I can just continue from there and check if sand exists, and maybe it will be able to check if dog exists, and maybe I will be able to get one of the answers, and that's a thought. uh, One another way that I am thinking it is, uh, this actually calls for recursion, because if the sentence was less is this cats and then I would have just try to find this much. If the word like cat was found, then my question would be like, how can I found this and dog? And if my word only cat was found, then I would have made like two branches, and branches would be like, yeah, this word exists, but maybe like some other word also exists if I have this cats, and maybe some other word can exist if I start from here. So kind of like combining a for loop and some kind of recursion is the initial approach that I'm thinking. And yeah, to be very honest, I'm thinking it because I have actually seen that this kind of problem requires DFS. So I'm actually setting my ground that yeah, I can identify the problem, and the recruiter loves that you can identify the problem, and then you can make a call that yeah, this could be done in the most effective way, not by brute force, but I would want to optimize. Like you can start with the word brute force, but I would want to use DFS. And maybe in the last video I told about subsets and DFS, and we make kind of a code that we can reuse again and again. So maybe we can just maybe you can just take a look at that and come back. But let's just start with coding this, and as we code, we need to think aloud the way it is expected in the Google interviews. So I will be using the font Consolas, that's just loved by Googlers. So if you can just use that one, and I will be just using const word break, and let me just see what inputs do I have. I have my s, which is a string. I have my word dictionary, word dict, and yeah, that's all the input that I get. The very first thing is I would want to have a global variable where I can store my result. So const result is equal to empty. Yeah, and the next thing would be like once I have my result, I would want also that my word dictionary is now a set. Yeah, so word is dict is equal to new set of this, and that's creating it as a set. Maybe I can just reuse the name, or maybe call it like words, or just dictionary, just to keep it simple. Yeah, this is just a dictionary, and this is my result. Now comes the next part, and I'm thinking about it like how can we make it with DFS. So we will have something like const DFS is equal to, and we would be having something like I, and the s and a slate. And let's just see that if this much would be possible to make with a slate, and it would be possible to make with this s. And we call DFS like this. So DFS with I would be 0, s would be s, slate would be empty, and we would just return the result. And if it is like coming in 2 pages, we can do 2 things. We can either make it pageless, which is like something that is okay, but I think that it is much better to just bring it to the next page so it can be seen. Yeah, so we would be doing that. So any of the options, I just love it when the whole code is on one page, and maybe it's easier for the interviewer also to see. So now that I have my DFS here, I would want to first provide my base case, like if my I is equal to s dot length, which is like if one of the things is like I know that with recursion this would be getting multiple branches or possibilities, like this word would be getting a possibility with this and this, but every time my base case will hit when my length of this string that I am catching, or I am getting an array in the slate, is equal to my s, or my input string. So once that happens, it means my slate is ready to be used as one of the outputs. So result would get a result dot push, and I'll be using slate dot join, and I will join it with a space so that we can have the, yeah, so we can have this kind of a space. So and we can just return. Yeah, so this is my base case, and this has been done, and I can just comment it with this. These are just some small things you can do, like comment could be in green, so we will write this is a base case. Yeah, after this I know that what I was gonna do is, and maybe this would make more sense once I have created it. So let j is equal to I plus 1. There is a loop that is starting from some j which is like greater than I, and j is less than I, and j plus plus. And this is going to capture my word, and we will just take a look how. So we have a for loop that is ready, and we would want to push, but only we want to push if the word is found, right? So firstly we would be making a const word is equal to s dot slice. We could use slice or substring, and we can just say I comma j, because I know that j would always be smaller, so it's actually j comma I. Okay, j comma I, that's good. And now we have our slice, and we can just think about how we can use it with the word dict or the dictionary that we have. So we can just see if dict dot has word, and if it doesn't, then we will just increment our j. But if it does, then we have found one of the words that exist, and maybe we can just push that word into slate. So slate dot push, and that word would be word. Once it is pushed, we can just call another DFS like, yeah, this word has been pushed, this word is okay, this word was found at j. Just try to find more words starting at j instead of worrying about, because this much has been filled. And this is like one branch that I've created, yeah. And the for loop would still go, like for loop is not stopping me, that if I have found cat, then it wouldn't stop me from finding cats, because this for loop would again go, and maybe the next time it will again find another word. So it will keep on going. As well as if one word is found, we are just making another branch, and we are just starting off from j. So we are just saying that, yeah, now a new word has been found from this word, from this particular letter index, and from there we want to just see if new words are possible. And to backtrack, or so that we do not accumulate the previous result, we want to slate.pop, and this is like one of the key things that would happen. It would get popped, and just taking a look at it, we can see that we are having something called backtracking here, and and we are creating another depth first search here. So yeah, this would be, I think, the solution. What we can do is right now go ahead and check it against ChatGPT maybe. So we can just see if we have just missed any of the important logic. Check if this JS code is okay for word break 2. Yeah, and let's just see if we have missed on any of the things. Yeah, we can actually omit this, passing this. So we have found that there could be some improvements specifically in the J. So let's just go back to that logic, and let's just see if what we can do better with that. So the thing is, we can actually start with I plus 1, but j should be less than s dot length, so that we could keep going forward. The logic here is that we want to start at the letter that we have from where we have already finished the last word. So we are starting from j, which is like 1 plus the last letter that we have found the last word on, and we are going to the end. And because we are starting and going to the end, then what we want to do is actually slice I to j. And yeah, so like we want to go from I plus 1 till the s dot length. So this must be less than equal to, and these are some of the very edge cases, like if you do not even like, if you miss out on this, the interviewer wouldn't mind, but at the same time he might be giving you a hint. Yeah, because we are starting with +1 maybe, and because the slice operation just excludes the last character, maybe we want to do something different here. And you would be able to catch up on like what he's talking about, because you were interacting with him throughout the whole interview. And this would be I think the right answer, and yeah, this is the correct answer for this. We can see that, or we can just dry run that, like what will happen. I think this is the most important part. If you are able to dry run your ideology and able to make him understand that you get it, like you get the point, like how it is working and why is it working the way it is working, then I think that is much more important than you getting the uh, picture perfect algorithm. So yeah, let's just think that we are going to try and with s is equal to cats and dogs, and word dictionary is equal to cat, cats, and sand and dog. So the very first thing is like, this would be called, because this is like a function inside a function, we have result which would be empty. So let's just make all the important variables here, and let me just color this thing. This is like our kind of our input, maybe a bit more accessible here. Yeah, and this is my result which is empty, and my dictionary which is like a lookup for all the important words. This is the same as this one, so it's just that this is an array, so we can omit it writing here. Just assume that this is a set instead of an array. That would be it. And this is our expected output, so I'm just going to write expected. Let's see how and why is it expected. So index is 0, string is this whole thing, and we have an empty slate. We think that firstly we would be going to the base case, so I would be 0, it would not be equal to s dot length, which is like 1 2 3 5 6 7 8 9 10. So it's 0 is not equal to 10, we don't go here. We have the j initialized at 1, j is less than s dot length, and j plus plus. We try to find that what's the first word, which is like s dot slice I and j. So I at the moment is 0, and j at the moment is I plus 1, which is greater than, and which would just give us the first letter that exists. The first letter would be checked against the dictionary. So is C in the word dictionary? We have no C. We have cat and cats, but no individual element as C in the array or in the set. So it doesn't go here. It will just keep on rolling and increasing our j. So we will again check with I and j, which is like, is CA there? It's not. We will just again increment our j. Is cat there? So cat exists in slice I of j. So the first thing that would come here is cat, with incrementation of j and I being at 0 at all times. And yeah, so we have found our first word. And now here's the cool part. This first word allows us to see if it exists in the dictionary. If it exists, we are pushing it, and we are pushing it, and we are calling our slate, so that our next iteration becomes, or our next recursion becomes something that starts at 0 1 2 3, and with j would be at 3, and something that has the whole string. We can actually totally omit the string because it is like globally available, but that's okay. And we have our word dictionary, which is outside. I mean, we have our slate that is having our first word pushed to it as cat. So we are getting there. I mean, this does not stop our for loop, but it actually creates like a branch. So yeah, this is its own DFS that will keep on going. So I can just write like DFS, and yeah, maybe just color it in a different way, because this is like implementing. Yeah, that's okay. So, and we pop it, so, and then so cat would not exist, and we go back again. And when we go back again, we have the, and I will come back to this DFS, but when we go back again, we have our word cats here, because my j has incremented, and my j has incremented, so my I and j would be giving me cats. and the dictionary will check it. Yeah, is cats there? So cats is also there. So this would actually again be ready for the next word with the J as 4 and the word as cats. So this is like trying to say that yeah, I am going to create two different branches, and every time you just give me a new word like cats, like this is available, this is available. So this is running its own DFS, this is running its own DFS, and both are ready to take on the next word in slate as a new item in the, and then finally get joined and return at the base case when I is equal to length. But yeah, let's just see. So because now we have two functions from this one function, let's think of like this was my original input, and this is the power of recursion. Like now just blank out on whatever you saw about the initial run and just think that these are my new function with these as my input originally coming from here, let's say. So my I is 3, my S is the whole string, and my slate is at the moment cat. Our I is not equal to this 10, we cannot push it. We can actually try to find the next word from I to J, which is like J would be equal to I plus 1, so it is like starting at 4, which is like starting with the word S. So we have 0, 1, 2, 3, 4. We would be starting at J plus 1, so this would be for cats, I believe. So we have this J, and let me just again run back a bit to see that if we are doing it the way that it should be, because we have started at 1 and that's how we got the word cats, and now we have this J as our I. And yeah, seems right. So the thing that would happen is now we would be just getting onto the next word, which would be sand for this and for this on incrementation of J until we find the dict dot has word. There could be a thing that this and this indices, I will have to just trace it with a pen paper to see if I'm on the right one, but I believe so. And the more important thing is if the logic is correct, which is like I know that my dict dot word would be checking the next thing that is possible for this and the next thing that is possible to for this, which would be like running into another DFS with the newer J indices. For cat would be about 4 characters, like 7 I believe, and C, and this would be like cat and sand because I have found it when I was running this function. So this exists as a DFS inside of it, just working its way to find if it can hit the base case or not, and sand. And same when this saw and, so it would also be having the similar kind of a function that exists when the word is found with cats and these both will be running. The for loop doesn't stop. We still have two more functions that will again try as a like they exist as the first existing function, and it will just call it back from here, and we would be again checking if the new words are found. So this is how we would be getting like and we would be getting dog. Once all of these exist, we would be actually coming back to our base case. So if I is equal to s dot length, once that is hit, we would be able to let's just say we would be able to get and dog in both of them, and the DFS would run. It would come to the base case, and then it would start to pop. The way it would pop, and it will just have the result turn into these and get these value like cats and dog and cats and dog, because the slate would be joined. So this is the slate, but this would get a join operation. And yeah, so more or less that is the whole logic and idea. I would want you to trace it with a pen paper, but when you are explaining, just make sure that you are able to take a smaller example. Could be anything that maybe this one, or maybe anything that is like more like apple, but the main thing intention is that you are able to understand, yeah, this collects the word, my for loop is still running, we are able to just send off in a different branch and see if this one, if started as a word, could have more possibilities. So making a problem into smaller problems and just breaking it at the base case when I is equal to s dot length, starting off at j is equal to 1 bigger, so we can just have this slice operation running correctly, and this would be let's say giving us the word cat, cats, and dog, and finally able to see if the word exists with a constant time lookup, and we are able to send another DFS call for it. So yeah, that would be it for this one. The complexity would be, because this has this join operation which has n for every time, so n, and because whenever we find a word, and it could be like the worst case could be like every time you hit another plus plus, you are again finding a word. Could be like my word dictionary has a in it, and my word would be like multiple a's that exist, so every time there would be like a new word that exists. So something like that would have a complexity of 2 to the power of n, sending different branches, as well as we have, like this is like usually for recursion what happens, plus because we are running a join, so n, this is the n to power n is the big O. Yeah, so this is done. We are able to have a basic understanding of how it is coming to the base case and how it is getting this word shift. And yeah, this is summing up that this is the word break 2. It is a lead code hard problem. It may be that something that could take a lot of your time. Just make sure that have this mentality that any question does not take more than 10-15 lines, and once you have that clear, and once you are able to use this kind of a DFS approach every time, these small things, if they occur, then they would be just sorted out between you and the interviewer who would be helping you. So yeah, make sure you speak out loud, make it very clear when you dry run, and yeah, just keep on watching this series. We will be having a lot of exciting and difficult question coming up. See you in the next one.